Hello guys, today we are going to talk about Laplace transforms 1. The first question is, what is Laplace transform? Laplace transform is just another way of solving an integration. Now the most important property of Laplace transform is that we can break any transform into n number of pieces and then integrate each separately and then combine them all together. What happens is that suppose you have two transforms like t into e raised to something, and you have to integrate this, then you will use uv rule to solve this. But by using Laplace transform you can find the integration of t separately, Laplace of t separately, and find the Laplace of e raised to something separately, and then combine them both to get the final answer. This is why Laplace transform is very important. So let's take the general form of Laplace transform, which is Laplace of f of t is equal to 0 to infinity e raised to minus st into f of t dt. Now this is the general form of Laplace transform of a function f of t, which is equal to 0 to infinity e raised to minus st into f of t dt. Now let's look at some of the important properties of Laplace transforms, or the list of Laplace transforms, which will help in solving us most of our questions. Now these are the important Laplace transforms. The first one is L, that is Laplace of e raised to at is equal to 1 upon s minus a. E raised to minus at is 1 upon s plus a. Laplace of sin at is equal to a upon s square plus a square. Laplace of sin h at is equal to a upon s square minus a square. Laplace of cos at is equal to s upon s square plus a square. Laplace of cos h at is equal to s upon s square minus a square. Laplace of t raised to n is equal to n plus 1 factorial upon s raised to n plus 1. Laplace of t raised to n is also n factorial upon s raised to n plus 1 if n is positive integer. Now what is the difference between these two? The difference between these two is that when n is any integer, be it negative or positive, you can use this formula. But if n is compulsorily a positive integer, you can use this formula to find the Laplace. Now Laplace of 1 is equal to 1 by s. Laplace of ERF under root t. This ERF is called as error function. This is a Gaussian error function, and its Laplace is equal to 1 upon s into s under root s plus a. Then Laplace of ERF c, which is error function complement of under root t, is equal to 1 upon under root s plus 1 multiplied by under root s plus 1 plus 1. Now the question is, what is s here? S is nothing but a function of phi of s, and there's one-to-one correspondence between this f of t and phi of s. What is one-to-one correspondence now? It means that if suppose you have in your house your mother and your father and you and your sister. Now there's one-to-one correspondence. No, there's many-to-one correspondence here. Like your mother has claim on you and your sister. Your father also has claim on you and your sister. But suppose if I remove father and sister from this picture, so there's only one-to-one correspondence, that is mother and you. So this is called as one-to-one correspondence, and here f of t and phi of s have one-to-one correspondence with each other, where t is mostly known and s is mostly the unknown. Now let's solve some questions based on this list of transforms which we just learned. Let's take a simple question. 4t square plus sine 3t plus e raised to 2t. We have to find the Laplace transform of this question. So let's proceed. Laplace of 4t square plus sine 3t plus e raised to 2t will be equal to Laplace of 4t square separately, which I told you which is the property of Laplace, plus L, that is Laplace of sine 3t plus Laplace of e raised to 2t. Now Laplace of 1 is 1 by s, but Laplace of any constant cannot be found, because when you integrate a constant, you always remember that the constant number comes out of integration, and then we integrate whatever is left inside. The same thing happens here. So 4 will come out. We have to find Laplace of t square only, and here there's nothing constant because this 3t is an angle which is with sine, so 3 cannot come out. So we have Laplace of sine 3t plus Laplace of e raised to 2t. Now the Laplace of t square can be found using the two formulas which we just saw, Laplace of t raised to n. Since this 2 is a positive integer, compulsorily positive integer, we will use the second formula which we learned, which is Laplace 4 into n factorial, that is 2 factorial, upon s raised to n plus 1, that is 2 plus 1. Laplace of sine 80 is a upon s square plus a square. So Laplace of sine 3t will be 3 upon s square plus 3 square. Now Laplace of e raised to 80 is 1 upon s minus a. Therefore Laplace of e raised to 2t will be 1 upon s minus 2. If we further simplify this, so we will have 4 into 2 factorial is 2 into 1, which is 2 again, s raised to 2 plus 1, which is 3, plus 3 upon s square plus 3 square is 9, plus 1 upon s minus 2. This will be 8 upon s cube plus 3 upon s square plus 9 plus 1 upon s minus 2. Now this is a very simple question. The trick is to first break the constituents into different parts and then find the Laplace transform of each of the constituents, and then finally do whatever is asked. Suppose it's asked to add, you add them. Suppose there's a subtraction sign here, you subtract it. There may be also multiplication, so you have to multiply it.